Hi, I'm Suraj Tarwadkar. In this video, I will be doing presentation on capillarity and Bernoulli's equation. What is capillarity? It is the rise or fall of liquid in the surface in small tube with respect to the adjacent general level of liquid when tube will be held vertically in the liquid. Here we can see a container in which there is water, and this is the general level of water, and there is atmospheric pressure acting on the surface of the water because container is open to atmosphere. This is a glass tube of diameter d which is inserted into the water, and sigma in the surface tension which acting on the liquid, and theta is the angle surface between surface tension and the vertical axis of the glass tube. When the tube is inserted in water, there will be rise of water into the tube to height h, and here there is a container in which there is mercury. This is the general level of mercury and atmospheric pressure acting on the surface of the mercury. As the container also open to atmosphere, there is a glass tube of diameter d which is inserted into mercury, due to which there is a fall of level of mercury from the general level up to a height of h. Sigma is the surface tension which acts at an angle from the vertical axis of the glass tube. For water, there is a rise in level of liquid, and for mercury, there is fall in level of liquid. So capillarity is the rise or fall of liquid in small tube with respect to the adjacent general level of liquid when tube is held vertical in the liquid. Now we will find out the expression to find capillarity rise. Under equilibrium, two forces are acting on the water inside. The first one is weight of water column, which is at a height of h, and the other force is the upward force acting on water due to surface tension sigma. So we will equate both the forces which is acting downward and the other which is acting upward. We will equate both the vertical forces. So first one is the downward force, that is weight of liquid W of height h in the glass tube, and second one is vertical component of surface tension force. We will enlarge the portion, so W is weight of water of height h in glass tube, and to find vertical component of the surface tension, we will resolve this force into horizontal and vertical component. Sigma is the surface tension which is acting tangentially to the liquid surface. So we will resolve it into horizontal and vertical component. This is the angle theta. So horizontal component is sigma sine theta and vertical component is sigma cos theta. W equal to weight of liquid, which is nothing but mass into acceleration due to gravity. We will write mass in terms of density, as we know density equal to mass into volume. So mass will be density into volume, and G will be as it is, right as it is. So density in written as rho, and volume is area into height. So area of glass tube, which is diameter d, so area will be pi by 4 into d square into h height. G is written as it is. Circumference of the glass tube into vertical components of surface tension will give us vertical component of surface tension force acting along circumference of the glass tube. So circumference into vertical component of surface tension, circumference is pi by d, and vertical component is sigma cos theta. So as we need to find expression for capillary rise, H equal to 4 sigma cos theta upon rho g d. Theta between water surface and glass tube is approximate taken as 0. Hence, cos theta will be equal to 1. So final expression for capillary rise equal to H force sigma upon rho g d. Now we will be talking about Bernoulli's principle. Bernoulli's principle. The flow of fluid is streamlined if every particle of the fluid flows exactly to the path of its preceding particle and has the same velocity as that of its preceding particle. Consider a fluid moves through a tube of area of cross-section A1 and A2 respectively. The volume of water entering A1 per second and the volume of water leaving A2 per second. Therefore, mass of fluid entering per second A1 and mass of liquid leaving per second at A2. Assuming there is no loss of fluid in the tube, that is for ideal fluid. Therefore, A1 is constant. This is the equation for continuity. When the fluid flowing through a section of pipe with one end having a smaller cross-sectional area than the pipe at the other end, the velocity of the fluid in the constricted end must be greater than the velocity at the larger end. Bernoulli's equation applies conservation of energy to formalize this observation. Consider a tube of AB of varying cross-sectional A1 and A2 and a difference height H1 and H2. Liquid is flowing from A to B. P1 is greater than P2. Here A1 is greater than A2. So P1 is less than B2. The force of liquid at A and B. Now the work done per second on the liquid at cross section A and at section B. Liquid V2 equals V. Equation of continuity. Net work done equals P1V minus P2V. The net work done per second is equal increase the potential energy and kinetic energy per second from A to B according to law of conservation of energy. Thank you.